For generations, higher education relied on a simple proxy for learning. If a student could accurately remember information and reproduce it on a page, institutions accepted that they understood the material. This system worked because gathering and synthesizing knowledge was a labor-intensive, entirely human effort. The final essay or exam score reflected the actual hours of cognitive work to produce it. Then came the speed and fluency of large language models. These algorithms generate complex text and logic in a fraction of a second. Today, a student can prompt an AI to write a polished literature review, output complex programming code, or solve high-level mathematical equations, tasks that universities used to spend weeks measuring. Because the final product can now be entirely outsourced to an algorithm, traditional assessments have lost their ability to verify that any human learning actually took place. To fix this, educators are shifting their focus. Instead of evaluating the static final product, they're assessing the steps a student took to build it. This means replacing the traditional single essay submission with a process portfolio. Students now hand in their prompt histories, personal reflections, and detailed rationales for why they revised the AI suggestions alongside their final work. They are also tested on disciplined skepticism. A student might be asked to run a bias audit on an AI's output, cross-checking its claims against primary sources to locate hallucinations or missing perspectives. In an explanation-based assessment, a student might use AI to generate the bulk of a project's content, but their grade depends on an oral defense explaining why they chose a specific prompt strategy over the alternatives. These structural changes make the student's own thinking the centerpiece of the grade, turning the focus back toward genuine human authorship. Implementing these new assessments at scale requires clear boundaries. Educators need a way to define exactly how much AI assistance is appropriate for any given assignment. This table shows the AI assessment scale, a 5-level framework used to redesign assignments across a spectrum of AI integration. At level 1, AI is completely restricted. Highly controlled environments, like in-class oral exams and real-time problem solving, are still used to verify a student's foundational knowledge without any external influence. Level 3 involves AI collaboration. Here, students can use AI for drafting and feedback, but they must modify those outputs to ensure their distinct voice remains intact. Finally, Level 5 is AI exploration. In these assessments, students and educators co-design solutions to complex problems, using cutting-edge AI as an active, creative partner. This framework allows institutions to verify human understanding while preparing students for the reality of an AI-integrated workforce. Evaluating complex process portfolios and collaborative projects requires a massive amount of time from our educators. This flowchart outlines the human-in-the-loop grading model, pairing AI speed with human oversight. While AI provides preliminary scores, it lacks contextual awareness for cultural nuances. Therefore, the educator reviews the preliminary work, overriding machine biases, correcting misinterpretations, and providing the final accountable grade. Ethical AI integration requires human judgment and contextual sensitivity to remain at the center of the assessment loop. This shift in assessment changes the foundational goals of higher education. Algorithms now handle computational and generative tasks. The cognitive domains universities must now prioritize include ethical reasoning, creative remixing, and leadership under uncertainty. When students use AI as material for thinking rather than a shortcut to an answer, the university transforms from an examination factory into an active innovation lab. Success depends on a student's ability to create, question, and achieve while working alongside artificial intelligence.